an object from interstellar space has been observed to visit our solar system.
That's the power of one of these asteroids. 10,000 Hiroshima bombs is the power packed by this piece of real estate a mile across.
Hello and welcome to Secrets of the Stars. For the very first time, an object from the depth of interstellar space has been observed making a visit to our solar system. Amidst the enigmatic mysteries of interstellar space, one phenomenon has captivated the world's imagination like no other. The inscrutable visitor known as Oumuamua. When it initially passed through our solar system in 2017, Oumuamua left scientists both bewildered and intrigued. Its peculiar cigar-like shape and its unexpected acceleration raised a multitude of questions. Now visionary Elon Musk has boldly announced the return of Oumuamua, and it appears to be accompanied by something else. The big question remains, what exactly is this cigar-shaped object? Is it an asteroid, a spacecraft, or something even more mysterious and otherworldly? Join us on this expedition into the unknown, guided by Elon Musk as we uncover the unimaginable and unexpected return of Oumuamua. Initially, Oumuamua appeared as a reddish, elongated rock resembling a colossal cigar-like shape that stretched about a quarter mile in length, making it 10 times longer than its width. Sunlight's radiation pressure might only contribute to acceleration if Oumuamua possesses an exceptionally low weight, which can be attributed to its distinctive form and sparse density. There are a lot of controversial theories about how that it aims to engage both the scientific community and the general public in considering Oumuamua as a potential extraterrestrial messenger. It urges readers to ponder the possibility of an encounter with beings from beyond Earth and offers a more in-depth exploration of the author's arguments, encouraging further discussion about the mysterious origins of Oumuamua. However, in 2018, as Oumuamua prepared to exit our solar system, the Hubble Space Telescope captured its final images, revealing an unexpected increase in its speed. Initially, scientists believed that this acceleration might be attributed to outgassing, where material escapes from a comet's surface due to the solar heating. Nevertheless, Oumuamua lacked a visible tail, and its abrupt acceleration posed a perplexing enigma since gravitational forces should have decelerated its motion. Furthermore, if outgassing has indeed occurred, it should have induced a noticeable and chaotic spin in Oumuamua, which was not observed. Instead, researchers like Viale, Loeb, and proposed that radiation pressure appeared to be most likely explanation for the increase in its speed. This development raised a perplexing question. If Oumuamua was neither a comet or an asteroid, what could it possibly be? This enigma continues to confound scientists, including its luminosity, shape, and acceleration. Defied absence of outgassing was a crucial factor. Elon Musk suggests that Professor Loeb's involvement in Project Starshot, which aimed to propel a small spacecraft to Alpha Centauri using a light sail and a powerful laser, influenced his hypothesis. When Oumuamua arrived, the idea of an interstellar probe aligned with his hypothesis. Careful calculations based on available evidence supported his concept, leading to a key conclusion: Oumuamua was likely not of natural origin. In early 2020, researchers put forth a captivating theory regarding Oumuamua, suggesting the possibility of it being a hydrogen iceberg. They proposed that pure hydrogen gas might be the driving force behind its propulsion, akin to a rocket. While this theory initially sparked intrigue, it faced considerable challenges upon closer scrutiny. A paper jointly authored by Harvard and the Korea Astronomy and Space Science Institute raised doubts about its feasibility. Professor A.V. Loeb and others expressed skepticism due to various issues. One major concern stemmed from the fact that the conventional processes responsible for forming solid objects like Oumuamua couldn't be applied to a hydrogen iceberg. Typically, solid objects form as tiny dust grains collide and stick together over time. Therefore, it's implausible for kilometer-sized hydrogen icebergs like Oumuamua to have formed because the dust grains couldn't grow larger due to the high gas density. Additionally, an object like Oumuamua couldn't have survived as long as journey if it were composed of a hydrogen iceberg. Such icebergs would rapidly evaporate during journeys lasting hundreds of millions of years, while the hydrogen ice theory could have been groundbreaking, explaining Oumuamua's cigar-like shape and non-gravitational acceleration. Scientists had other theories to explore. In September of 2020, a fascinating theory emerged regarding an elongated space rock known as Oumuamua, likened to a colossal dust bunny formed by clumps of dust and debris due to static electricity. Elon Musk explained that scientists considered Oumuamua a giant version of this common household phenomenon. The original comet, Oumuamua's parent, was probably a long-period comet which takes a considerable time to complete its orbit around stars and often ventures far from due to weak gravitational pull and radiation pressure. Oumuamua eventually separated from its parent comet, entering interstellar space. Initially met with skepticism, the nitrogen iceberg theory gained support among astronomers, including those not involved in the study. They found it plausible that Oumuamua could be a piece of an icy dwarf planet. However, the case was not closed. In their research, scientists examined how different types of ice made up of hydrogen, nitrogen, and oxygen behaved under similar conditions. Surprisingly, they discovered that a significant chunk of nitrogen ice could exhibit the same characteristics as Oumuamua. The challenge lay in measuring nitrogen gas, which telescopes at the time struggled with. According to Musk, the researchers also identified potential sources of nitrogen icebergs such as dwarf planets and celestial bodies at the distance of the fringes of solar systems, like Pluto and Neptune's moon, Triton. These objects are known to have nitrogen ice on their surfaces. Elon Musk elaborates, stating that based on their findings, the authors proposed a theory suggesting that during the early stages of formation in a distant solar system, collisions between planetary bodies occurred, leading to the detachment of a chunk of nitrogen. As the nitrogen iceberg ventured into our Milky Way over time, it eroded and eventually assumed a flattened pancake-like appearance. This concept put forth by scientists aligned well with their observations, and other astronomers found it sensible and praised its explanatory power. However, this theory had some gaps. Professor A.V. Loeb and Amir Siraj presented an alternative argument, suggesting that the presence of Oumuamua implies that there are likely many more similar objects in our galaxy. However, the count of exoplanets in our galaxy is relatively low. The dilemma in the two possibilities it led to either Oumuamua is not entirely composed of nitrogen, or our estimates of the number of exoplanets are significantly off the mark. To unravel this puzzle, researchers examined whether there was enough material within the Milky Way to create all these nitrogen icebergs, or not. Musk discovered that our galaxy, to generate as many nitrogen icebergs as it does, it would need to transform 10 times the mass of all the stars into the substance known as exoplutos. However, even with the ambitious perspective, a star system can't possess sufficient nitrogen ice to create such a vast quantity of exoplutos. It probably originated from the general vicinity of the prominent star Vega roughly 300,000 years ago. However, it's important